next set is the whole numbers. The whole numbers start with a whole. And a double-legged W there. So what number looks like a whole? Huh?
0.
0. So the whole numbers start with 0 and then they go up. So, my question to you. Are there more natural numbers than whole numbers? Are there more whole numbers than natural numbers? How do you know? How many natural numbers are there? How many whole numbers are there? Infinity. So are there more whole numbers than natural numbers? Oh. If you're going to compare two sets, you have to be able to count the two sets. So can we count the number of natural numbers? No. Craziness. Alright. From there, we're going to add the integers. Integers. So what letter do you think represents the integers? I might be. Okay, let's be honest. It's okay. Doesn't matter. So integers. That is actually a Z. Alright. That is a Z. So, of all the people in this room, Stefan is the one that should probably know why that is a Z. No. Strongly disagree, sir. Do you have a word for numbers that starts with a Z? Yeah. Zahl? Son? Okay. So, German for numbers, basically. That's where the Z comes from. And these are what I call the number line numbers. So it includes positives and negatives. So it starts with dots. It ends with dots. Starts with dots, ends in dots. Basically the numbers you normally see on a basic kindergarten number line. Or you should see. You should see the negatives. Not that they're always there. Okay. So, are there more integers than there are whole numbers? Something you can ponder in your pondering life. Rational numbers. Rational numbers. This one is a Q. Now this one we don't have specific examples, we kind of just have definitions. I'll come back to why it's a Q. Any number that can be written as a fraction. Any number that can be written as a fraction. So would that include decimals? Some of them. 0.5. Can you write 0.5 as a fraction? Yep. So that is what we call terminating decimals. So it includes terminating decimals. That means decimals that stop, like a terminal, airport terminal. That's where your destination ends or begins. So 0.5 equals 1/2. So terminating decimals are rational numbers. And then repeating decimals. Most common examples, 0.3 repeating is 1/3. Okay, so terminating decimals and repeating decimals are both rational numbers as well. So what would be the opposite of rational? Irrational. Oh, the Q. Let's go back to the Q. Q stands for the quotient. And what do you call the answer to a division question? The quotient. And what does a fraction represent? A quotient. Okay, so if you have 1 over 2, that is 1 divided by 2. It's a division problem. All fractions are division problems. So when you divide, you get a quotient. So that's where the Q comes from. Okay, so irrational, this is going to be an I. This one makes sense again in our language. Okay. So this is any non-repeating, non-terminating decimal. Any non-repeating, non-terminating decimal. So it has to go on forever and it's not repeat. Most common example is pi. So examples, pi. Square roots are going to be irrational. So the square root of 2, any sort of root, square root of 3, square root of 25. Because that simplifies to 5. So that would be what kind of number then? Natural, whole, integer, and rational. It'd be all of those. One that usually gets them is if you have a pattern. So if I go 0.212212221 ... Is this a repeating decimal? Okay, so the 2's are increasing. There's a pattern. There's definitely a pattern, but it's not a repeating decimal. Repeating decimals is if you have 2 1 2 1 2 1 2 1 2 1 2 1 2 1. It's the same digits over and over and over and over and over again. Okay. Okay, we're getting there. The real numbers. Double-legged R. That is the combination of the rational and irrational. It's a combination of, you put the rational and irrational to get numbers together, they make the real numbers. The real numbers includes everything. So it doesn't really seem right to say there are as many real numbers as there are natural numbers. Okay, I get that. It doesn't seem right. What they do have is they have something called the cardinality of infinity, and they basically have different sizes of infinity. So they're all infinity, but they have different sizes. Yeah, crazy stuff. Let's not get into that. Okay, but these are not all the numbers that we have. Which ones are we forgetting that we reviewed earlier a few weeks ago? Imaginary numbers. So if we put the imaginary with the real, what did we call those? When you have an imaginary part and a real part. Complex numbers. Aren't you glad you came today? That's going to be a C. So this is a combination of the real numbers and imaginary numbers. There you have them all. Your school journey has come to a conclusion. You finally got all the families and numbers. You're set for life. You can now be successful. Yep, we're done. You can graduate. Okay. Some of this we've done interval notation before. That's going to show up again. We haven't gone over set builder notation. A lot of this first section is just some vocab terminology. Okay, so set builder. Now, if it's a set, what do we have to use? Okay, you got to use the brackets. So we're going to start with the brackets. And this is going to use some mathematical shorthand that when you read it, you have to translate it into English. So I'm going to start with a variable, and I'm just going to draw a vertical line. This vertical line stands for the words such that. Math is its own language. What you say for the first part is you're going to say the set of numbers x such that, and now this next part is going to be our restrictions on what we want. So let's say I want x to be greater than 4. Okay. So the set of numbers x such that so this one right here, this is, you don't say this, but this is just going to be the restrictions for the given value. Those are the restrictions. So you'd say such that x is greater than 4. There's going to be a comma, one more part to this. And I'm going to say x, remember a subset symbol, but this kind of looks like an E. It kind of looks like a C with an E. So it's not a true E. It looks like a combination of an E and a C. And this is where the shortcuts for the sets of numbers will come into play. So that symbol right there, think of an element of. So that is, when you read is an element of. So we'd say x is an element of the natural numbers.